Okay, this is section 11.5 and it's called partial sums. So what we're doing is we're taking series and we're adding up a certain amount of the series and we're seeing what we get. That's why it's called partial sums. There are ways to play with infinity and get the entire sum of different sequences, and we'll talk about that a little bit, but first we need to get comfortable just applying these formulas, okay? And these formulas are as written, where in an arithmetic series, okay, you take the first term and the last term that we're looking at, and we divide this by n over 2, and I'll show you how to do that. We'll do an example next. For a geometric sequence, it's take the first term and multiply this all against 1 minus the ratio to the nth, so whatever n we're going to, all divided by 1 minus this ratio, or the multiplier is what I've been calling it in class, okay? So get these equations into, or these formulas into your notes, and we'll start to play around with them in the next example. So as we talked about in class, we know that we want to call this the 0th term, but unfortunately these books and some old school thinkers still think of this as the first term of the series. So if we wanted to find the 0th term, we actually need to, this is add 3, we'd actually have to subtract 3 to get 1 as the 0th term. So now, for now on, when we see t of 1 in the book, we mean literally the first term now, okay? And that's something we're going to have to get used to, and we talked about in class why this is the case. Okay, so let's find the sum, okay? The sum of the first 10. If we were writing this in sigma notation, this is the same as saying do all of this from k equals 1 to the 10th number of whatever this sequence is. This is t to the 0 is 1, so the equation for this sequence is, let's see, 3n plus 1. Again, 3 comes from my difference generator, and the 1 comes from my initial value, which we had to go back and find. Okay, so we're going to try to find s of 10. And the way we do that is we just plug it right into our arithmetic formula, okay? So s is going to 10, so we're going to say 10 divided by 2 is equal to the first term, which was 4, plus the nth term, which is, we would need to find t of 10. So t of 10 equals 3 times 10 plus 1. So this equals 30 plus 1, or that it's 31. So now I can write t of 10 right here as 31. And now I'm just doing simple arithmetic. So this becomes 5 times 35, which if I plug this into a calculator,
5 times 35 is 175.
Okay, so here's a geometric series. So again, we're given t of 1, t of 2, t of 3. We need to find t of 0. So we'll divide by 3, which will give us 2/3 is t of 0. If we want to look at the sum of the series to 6 terms in sigma notation, we can rewrite this as k is starting at 1, and we're going up to 6. And we need to put in the function. The function here is 2/3, our initial value, times, let's see, our multiplier, which is 3 to the n. Okay? From here, we can plug this into our formula. Our formula for geometric sequences, or series, is the first term times 1 minus r to the n divided by 1 minus r. So we'll start to plug this in. The first term is 2, so this is going to be equal to 2 times 1 minus, what was our r, or our ratio, or our multiplier, is 3. To how many n's? Well, we're going to the 6th n. All divided by 1 minus 3. Okay, from here, this is a lot of calculator work, so I'm going to duck out and do that real fast. So if you did the calculator stuff, you would have gotten that S of 6 equals 728. Okay, so the new idea here, guys, is that all these series, whenever you see a sequence, you need to recognize that it's starting with t of 1. We're going to use our stuff to figure out the formula for the initial term, t of 0. And then we're going to plug all this into a formula, depending on if it's geometric or arithmetic. We'll practice more of this in class and go over it some more, but you guys have the bases now by these notes. If you have any questions or comments, please let me know. Okay, here's one more example of an arithmetic series, and we're going to find the partial sum up to the 13th term as given by this subscript right here. Looking at my series, because I'm adding. I know this is t of 1, t of 2, t of 3. As we talked about, now we have to find t of 0 to make the equation for t of n. Okay, so it looks like I'm, what am I doing? I'm adding by 11. So add 11, add 11. So I'm going to subtract 11 to find the t of 0th term, or the 0th term, which is going to be minus 9 is 0, minus 11 would be negative 2. So if I were to build an equation for this, okay, it's going to be t of n equals 11n minus 2. Minus 2. So here's my equation. And if I want to represent this in sigma notation, I'm going to write it such as we're going from the first term to the 13th term of 11n minus 2. And we have a formula for this, so we're going to use it. It says that if we take 13 over 2, and we multiply this by the first term and the last term. So here's t of 1, so 9. And we're going to have to find the last term. So down here I'm going to do t of 13 equals 11 times 13 minus 2. Going to need a calculator for that. Let's see here. Okay, so 11 times 13 is 143. 143 minus 2 equals 141. Okay, so I'm going to put in right here 141. And it seems we have 150. So 13 divided by 2 times 150. Okay, and let's see what that gets us. 150 times 6.5 equals 975. So if we add up all the terms from the first term to the 13th term, we're going to get 975 as the answer. Again, what I did here is I found t of 0, I made an equation, I set it up in sigma notation, and then I applied the formula to find partial sums of the arithmetic series. This required me using the first term and then the last term denoted by what we're going up to. So I had to find that using my formula, and then I just plugged it into my equation and got 975. Okay, here's one more example of a geometric. So this series, and since we're adding, we know this is t of 1, t of 2, t of 3. If we want to find t of 0, okay, it's going to be here. And what are we doing? We are multiplied by 2, multiplied by 2. So if I want to find t of 0, it's going to be divide by 2. So t of 0 looks like it's going to be 1/2. If I want to build an equation for this, it's going to be t of n equals 1/2 times 2 to the n. Okay, so and now I'm trying to find the series added to the 5th term. If I want to put this into sigma notation, it's going to look something like this, where I'm going to start at the first term. I'm going to go up to the fifth term of my equation, 1/2 2 to the n. And then this has a formula that we follow. So the geometric partial sum says that we take the first term, which is 1, and we multiply it to 1 minus r. R is our ratio or our multiplier, so 2. To the n that we're going up to, which is to the fifth one. Okay, all over 1 minus r. So I'm going to need a calculator, am I? Let's see, 2 to the fifth is 32. So I'm looking at 1 times 1 minus 32 all over -1. So this is going to give me -31 divided by -1, which just equals 31. Okay, so if we were to add up all the numbers from the first one to the fifth number of this series, we would get 31. Again, how I did this is I used what I know about sequences to find the 0th term. This allowed me to make an equation. And then I could put it into sigma notation and apply the geometric formula. And then it's just arithmetic and other stuff from there. And we get 31 as the answer.